Good day, viewers. My name is Ayola Ridwanulai Ayomide with the matric number 15/25PC046 from the Department of Educational Technology, Faculty of Education, University of Ilorin. The targeted audience for this presentation are J.S.S. 2 students. Now, let's start with today's topic, which is the simple machines. The following are what will be learnt in this topic: the definition of simple machine, the history of simple machine, and the examples of simple machine. Now, the behavioral objectives of this lesson. At the end of the lesson, the student should be able to: 1. Define simple machine. 2. Gives a synopsis, which is brief history of a simple machine. 3. List and explain some examples of simple machine. Let's start by defining a machine. A machine is a device that is used to make job easier. In other words, the machine allows you to use less force to complete a task. Therefore, a simple machine can be defined as a mechanical device that changes the direction or magnitude of a force. In general, they can be defined as the simplest mechanisms that use mechanical advantage, also called leverage, to multiply the force. Also, simple machine can be regarded as the elementary building blocks of which all more complicated machines, sometimes called compound machines, are composed. For example, wheels, levers, and pulleys are all used in the mechanism of the bicycle. What they are trying to say here is that the building blocks of a bicycle are wheels, levers, and pulleys. Without these, the bicycle cannot function and cannot be movable. Let's continue with our definition. The mechanical advantage of the compound machine is just the product of the mechanical advantages of the simple machines of which it is composed. The next subtopic is the history of a simple machine. The idea of a simple machine originated with the Greek philosopher Archimedes around the 3rd century BC, who studied the Archimedean simple machines, which are the lever, the pulley, and the screw. He discovered the principle of mechanical advantage in the lever. Archimedes' famous remark with regards to the lever: "Give me a place to stand on and I will move the earth." However, the Greek understanding was limited to the static of simple machine and did not include dynamics, the trade-off between force and distance, or the concept of work. During the Renaissance, the dynamics of the mechanical power, as the simple machines were called, began to be studied from the standpoint of how far they could lift a load, in addition to the force they could apply, leading eventually to the new concept of mechanical work. Continuation. In 1586, the Flemish engineer, which is Simon Stevin, derived the mechanical advantage of the inclined plane, and it was included with the other simple machines. The complete dynamic theory of simple machines was worked out by Italian scientist Galileo Galilei in 1600, in which he showed the underlying mathematical similarity of the machines as force amplifiers. He was the first to explain that simple machines do not create energy but only transform it. The last subtopic, which is the examples of simple machine. The following are examples of simple machine: the lever, the pulleys, the gears, the screw, the pulley belt, the hydraulic press, the inclined planes, and the wheel and axle. Beside the listed examples is a diagram which illustrates each of the examples listed. Now, we will be talking on some of the examples of simple machine. The first one we are going to talk about is the lever. A lever is a rigid bar which is free to move around a fixed point, e.g. a screwdriver. A lever are divided into three classes, which is the input force, the output force, and the fulcrum. Underneath it is a diagram which illustrates an example of a lever, which is a screwdriver. As you can see, you can cite the input force, the output force, and the fulcrum in the image illustrated below. The next example we are going to talk about is the pulley. A pulley is a simple machine that uses a grooved wheel and a rope to rise, lower, or move a load, e.g. a flagpole. Underneath it is an image which illustrates an example of a pulley. As you can see in the image, you can see the load, the wheel, and the rope tied around the wheel, and what's it called, a diagram in human form which is pulling the rope. Another example is the gears. A gear is a component within a transmission system that transmits or transforms mechanical energy to match the requirements of an application. As the operating point of motors is generally at higher speed than the application requires. A gear can also be defined as a wheel with teeth along its rim. Below is an example of a gear. Another example is the wheel and axle. A wheel and axle is a type of simple machine which consists of two discs or cylinder with different radii. The image below is an example of a wheel and axle and how it operates. Another example is the inclined plane. The inclined plane trades distance for force by reducing the force needed to work against gravity, e.g. the stairs, the ramps, and the screw. Below is an image which serves as an example of an inclined plane. The next example which we'll be talking about is the hydraulic press, which is also the last example that we'll be talking about. Hydraulic press is a device in which a small force or a small piston is transmitted through an enclosed liquid and applies a large force on a large piston. Below is an image illustration of an hydraulic. Thank you all for listening.